we are going to talk about gas stoichiometry. The stoichiometry involved with equations that are gaseous. So the first thing we're going to do is we're going to use the equation. We got propane C3H8 in gas form plus 5 oxygens as a gas is going to give us 3 carbon dioxides, which is a gas, plus 4 waters in gas form. Now my question to you first off is, what type of reaction is this? What type of reaction do you need oxygen for and you get carbon dioxide and water? It starts with a C. Combustion. Shh. Gentlemen. Alright, so this is the equation. I'm going to show you a couple different ways to do this one. What is the volume of oxygen that is needed for the complete combustion of 4.00 liters of propane, which is the C3H8, and we're going to assume constant temperature and pressure. Otherwise, we'd have to do some other things. We're going to talk, the next set, when we get to volume and mass, or whenever when you don't have constant temperature or pressure that you're dealing with, you're going to have to use the ideal gas law to figure out stuff. But since we don't have that right now, we're good to go. It's constant temperature and pressure, so we're good to go. All right, the only thing that we know, what do we know? We know that there's 4 liters of propane, and we want the volume of oxygen. Now, if we just do the plain old stoichiometry process, the unit analysis from here, and we start with 4.00 liters of C3H8, we have to use, and we have to remember what molar volume is. And it's 22.4 liters per mole. Now, in order to memorize this number, because the chart that's over there won't be there when you take your quiz on this, I always remember just 2 plus 2 equals 4.
And 4 plus 4 is 8.
But that has nothing to do with this number. The 2 plus 2 is 4. So that's the way that I remember this number, 22.4. Alright, now, we have to go from liters to moles. So I need liters of C3H8 to moles of C3H8. And I need to use molar mass, or molar volume in this case. So I need to use the 22.4. Now, so this is, we went volume to moles, and now we need to go moles to moles. So moles of C3H8 to moles of O2. So now, that's going to be the moles C3H8 And so we need the moles of O2. Here is going to be the molar ratio. So in this case, in the equation, what's the mole ratio of propane to oxygen? 1 to what? There's a 1 here. 1 to 5. So 1 mole of C3H8 to 5 moles of oxygen. And then, since we need volume, we have to get out of moles and back into volume. So we need moles of O2 to liters of O2, and that's 1, and that's going to be the 22.4 again. Because remember, 1 mole of any gas is always going to be, we're always going to use the 22.4 liters for 1 mole of gas. So, now, let's just do the multiplication. 4 divided by 22.4 times 5 times 22.4 is equal to 20. So we get 20.0 liters of oxygen. Now, my question to you is there any way that we might be able to make this a little bit easier of a problem for us? Is there something, I don't know, we might be able to divide out, or... Yeah, so, the 22.4s divide out, and these two will say divide out. I'm going to divide those two out. I know. But what this does is it keeps the mole ratio intact. Because then we could just say, if it's just volume to volume, we could just say 4.00 liters of C3H8. And then go to the equation and say 1 mole of C3H8 is 5 moles of O2. But even if you want to think of it in a different way, you can also think of this in terms of, like, instead of saying moles, we can think of volumes. So you could say this is really 1 volume of propane to 5 volumes of oxygen. Because basically, if we remember, 1 mole of a gas is the same for any gas. It's the same amount. It's the same amount of volume. It's the same amount of particles. It's the same amount of everything. So we can kind of think of, so I'll put this here. Think that moles can be volumes. And that's just another way to think of the mole, because it's going to end up being the same thing. So it ends up being just 4 times 5, which is 20.0 liters of O2. So all we really need is the mole ratio, which gives us a ratio of the amount of volume that we have. Because for every 1 volume of propane, we need 5 volumes of oxygen. And that's going to give us 3 volumes of carbon dioxide and 4 volumes of H2O. So that's kind of new. But any questions on that one?